This video is going to help you remember how to find factors, zeros, and their multiplicity, and what the effect is on the graph. So we're going to start with functions either being in standard form or factored. So standard form or factored form. And standard form we'll remember is when we see like x to the fourth, x cubed, x squared, all the different parts in descending order. Whereas factored form is when we see all these little groups in parentheses. So looking at what we are given here, this is a standard form. So we don't know what these factors are yet, which means we need to factor it. So I'm going to come over here on my right side so that I can factor this. And when we factor, we always look for a GCF first. So I see that this has a GCF of x squared. So I'm going to factor out my x squared, and I'm left with x squared minus 2x minus 8. Now I can use the M method for this middle information, the polynomial, excuse me. So we get negative 8x squared, so our magic numbers need to multiply to negative 8 and add to negative 2. So 4 and 2 would work, and if we need it to be negative, we're going to choose negative 4x and positive 2x. And then we slide down those first and last terms, the negative 8 and the x squared. And I'm going to put this all in parentheses so that I'm not forgetting this original x squared that I had factored out in the very beginning. Okay. Now I can use grouping, and I want to find the GCF of each group. All right, and once I've done that, these two groups should match, so that's good. Again, we don't want to forget we have this x squared out front. So rewriting this with each of my factors, we'd have x squared, we have the x minus 4, and then these last two pieces create the final factor. So I'm going to list these factors. Something I want to note is that the factor for x squared, if we're solving this for the 0, we end up with just x equals 0. So the factor is really just the x itself. The squared is telling us that it's going to have a multiplicity of 2 because it is a repeated value. So we get x equals 0, and a multiplicity of 2. Listing the other factors, we have x minus 4 and x plus 2. Well, to solve each of those for 0, you can set each equal to 0. And when you solve, you would get x equals 4 and x equals negative 2. Multiplicity, we remember, is the number of times a 0 occurs. So looking at our answers down here, x equals 4 is only occurring one time, so it's got a multiplicity of 1. And the same thing for x equals negative 2. So I'm going to move my GCF here so I have a little more room. Okay, so now that we've found the multiplicity, remember that an even multiplicity is where it touches the x-axis, and an odd multiplicity is where it crosses the x-axis. And that's happening at those zeros. So multiplicity of 2 is even, so it's going to touch the x-axis here. And then each of these are a multiplicity of 1, so it's going to cross through. So now we can sketch the effect. This is going to be our x-axis down here. So I notice I have x equals 0, I have x equals 4, and x equals negative 2. Those are going to be my zeros, my x-intercepts. But we need to consider what the end behavior might be before we can graph. So we need to think about end behavior. There's a video on that if you need to check it out. Look at your original function, x to the 4th power. 4 is our degree, and we have a positive leading coefficient. So that's going to look like this. Our end behaviors are both going to end going up. So I'm going to draw little ends going up. So my first step is the ends. My second step is the x values. Figure out what's happening at those. So at -2, it's crossing through. So I'm going to just draw a dash to show crossing. And I know it's going to have to go like this because they have to connect. At x equals 0, it's touching. So I'm going to point it down because that's where I'm already at with this piece. And then at x equals 4, it's crossing. And again, I'm just connecting the pieces here. So that last step is to kind of connect your lines. And so this blue curve is not the prettiest. You can graph it in Desmos to check. But this shows you what it should look like. So you can just check Desmos if you want to be sure. And then one more quick example to look at for these. So this was in standard form, but here's the same example where we see it's already in parentheses. So we have factored form here. So we don't need to factor this. It's already in factored form, which means it's a little bit easier because there's a little less work to do. So these are our factors. We have x plus 7. We have 2x plus 1. And x minus 4. So if we solved each of those for 0, again, you'd set them each equal to 0. X plus 7 equals 0, 2x plus 1 equals 0, and x minus 4 equals 0. Solving them, you'd get x equals -7, x equals -1/2, and x equals 4. Now that we have the zeros, we need to find the multiplicity. So for the multiplicity, when we're in factored form, we want to look at the exponents of the factors. In factored form, check exponents of factors. So x plus 7 has an exponent of 2, meaning the multiplicity is 2. That factor occurs twice. 2x plus 1, there's no exponent there, so we can assume that's only occurring one time. And x minus 4 has an exponent of 3, meaning that factor is repeated 3 times, so the 0 is repeated 3 times. So then, remembering our odd and even rules, this is going to touch the x-axis, and these two zeros, it's going to cross through. So now we'll make this little sketch. Oh, that's going to mess everything up. Okay, so I don't have -7, so I'm going to improvise a little bit and just draw a -7. I hope you are okay with that. And we need to figure out this end behavior. So remember, step 1 is the ends. So we don't have our standard form, so this is a little harder to decide. But we can get our degree from adding the multiplicities. So if our multiplicities are 2 plus 1 plus 3, that gives us a degree of 6, which is even. And our leading coefficient, we just look at the front. There's no negative sign, so we can assume the leading coefficient is positive. So it has to look like this. The ends are going to be going in the upward direction. Step 2 is our zeros, our x values. So putting in all those points, x equals -7, and it is touching at that point. So I'm going to do a little curve. X equals -1/2. It's crossing through at that point. And x equals 4 is also crossing through at that point. So then your last step is to just connect your little curve marks that you've made. So they should connect and be on the right side. If they're not connecting, then try flipping what you drew on the other side of the axis.